So the new book again is Everything is Predictable: How Bayesian Statistics Explain Our World. All right, Tom, nice to see you. Thanks for coming on the show.
Absolute pleasure.
What's your story? How'd you get into Bayesian reasoning?
So, okay, I was just thinking about this actually. I mean, firstly, I've always been fascinated by it because I don't know how much you know about it. I'm sure it's come up in the past. Talking of, you're a skeptic and sort of the whole skeptics with a K movement. I was hanging around on the fringes of that years ago, and people like Ben Goldacre were part of it, and he used to write about it in his columns back in the 2000s, and I found it fascinating. Both my previous books that you mentioned discuss it because I find the sort of fundamental idea that you can do some test that's 99% accurate and get a positive result on it, and it not be 99% likely that you have the disease it's testing for. I find it's so counterintuitive and strange. I find it really interesting. But so I've always loved it, found it fascinating, found it explains so many different things. But the very specific reason why I wrote this book is more petty than that, which is that the last book, How to Read Numbers, that had a chapter on Bayes. I wrote an article based on that chapter for a UK newspaper, for the Observer, and the one of the editors put into the online furniture, the sort of the stand first, what the Americans would call the deck of the article, how an obscure theorem explains the world. And the word obscure drove statisticians mad, absolutely mad. I was at the center of this Twitter storm for like 3 days, people yelling at me like, it's not obscure, it's the most well-known theorem in probability. And I was like, yeah, that's true, but on the other hand, 90% of people probably haven't heard of it. Anyway, I could sort of see both sides, but it got people so angry that I'm going to write a book about Bayes then. I'm going to write a whole book about Bayes just to annoy you. And I have, and there it is.
I love the book. I listened to the whole thing on audio and then went back and read some of the parts to look at the cool graphs and charts and illustrations you provided in the book.
Thank you.
But just in general, there is a sense among skeptics, or just people in general, maybe, that the average reader doesn't understand statistics and numbers. The media tends to want to dumb down things. And I'm not sure that's true. I mean, if you look at the sports page or the weather page or the business sections, they're loaded with stats and numbers and graphs and charts. So to what extent is this meme that, people are just, they freak out when they see an equation and they can't get past that? What are your thoughts on that?
So this was very much the premise of the last book as well. That actually, people, when they have to understand things, quite capable of it, or when they want to, when it's relevant to their lives, like with COVID, I remember my last book sort of came out fairly early on in the COVID pandemic, and I remember thinking, this is amazing. People who would tell you in conversation they're rubbish at maths and don't know how to do maths, suddenly they've got the hang of the R value. You're like on 6 o'clock news in the UK, people just saying, and the R value has gone up to 1.3 today or something like that. And people say, oh, right, okay, that I now understand. I understand the reproductive, and they would be quite happy talking about, about the statistics of vaccine trials and all this sort of stuff. Because people needed to understand it for their lives, they got good at it. So I think people are quite capable of understanding most of this stuff, because it's not complicated, right? Like Bayes' theorem in particular. It's multiplication and division. My 8-year-old daughter could do that without difficulty. The steps required to do it. It's conceptually strange in ways, but I think most people are capable of understanding a lot of this stuff. With stuff like sports stats, actually, I think that's an interesting case because it is there are ways of doing it well and ways of doing it badly, right? There are ways of sort of using statistical models to try and predict and understand how well players are playing and how well teams are doing and things, but there's just like, this is the first time that a team from West London has won has won the third game of the season on the 17th, whatever, you can cherry pick weird stats and pull out interesting things, and they don't tell you anything. And if you're not careful with stats, it can sound like someone's telling you and saying something useful, but it's not. But there are also ways of using statistics in informative ways, and I think increasingly in sports particularly, that's becoming more of a thing, the sort of the Moneyball era,
Yeah, I love the Moneyball stuff. The movie, of course, was great. The problem is that if everybody's using the Moneyball program, then no one's going to gain an unfair advantage over anybody else.
Yeah, it's like the Dawkins thing, isn't it? Or Darwin, like if all the trees in the forest grow really tall, none of them get any more light. Yeah. It would make more sense if they didn't. Right. Yeah.
Yeah, exactly. Yeah. Well, I like Bayesian reasoning. I know a fair amount about it. I have a lecture on it in my Skepticism 101 course, and one of the chapters in my next book on truth is on Bayesian reasoning and signal detection theory. I think they're related, as well as statistics and correlations and all that. We can get into all that. What I like about it conceptually is that it allows you to engage with people who think differently from you without just shutting them off, or vice versa, by just saying, well, look, you might be right. I'm not saying it's zero.
Yeah.
The never apply a 0 or 1, the Cromwell's rule. Yeah. To any claim. Anything could be possible. Maybe the aliens are here. You might be right. Bigfoot could just be around the corner. We may see him tomorrow. I'm just telling you, so far, I haven't seen anything convincing yet. But I'm willing to change my mind. Go ahead and show me. And then that kind of takes the wall down of this kind of competition between what's true and what's false, and I'm right and you're wrong. And just like, okay, this guy's reasonable. He's got an open mind. All right, let me see if I can convince him. And then it turns on the arguments and evidence rather than personalities.
Yeah, I think that's one of the most crucial takeaways for me from the whole book, from the whole sort of project I've been on with this book, is that you shouldn't think in terms of things are true or false, or things are going to happen or not going to happen or whatever. You should think, how likely do I think this thing is to be true? How plausible is, do I find this belief? And you might be, you might say it is incredibly likely to be true. It's 99.999% or whatever. You very rarely have beliefs that confident, but nonetheless, sometimes you should. Or you should say it's almost certainly not going to happen, 0.001, but whatever. But you should always say, you should never, you can't be certain about anything, so it's just a question of how confident am I, and then that lets you adjust your belief up and down as new evidence comes in, and you never have to have this rigid it is or it isn't, and then have this horrible moment where you have to either defend a belief in the face of evidence or accept that you've been wrong all your life. You can move up and down, you can sway with the wind, as it were.
Yeah. I remember back in the 2016 election when Hillary was projected to win. She had like a 70% chance of winning, and then Trump wins. Well, why were the experts wrong? Well, they weren't wrong. They, if they ran the election 100 times, Trump wins 30 of them, and this is one of those.
Yeah, that was Nate Silver, wasn't it? Poor old Nate Silver.
Yeah,
who like, and in his defense, right? Lots of the other people, not that he needs any defending. He made a perfectly reasonable, prediction, and lots of the other pollsters had sort of 99% likely that Clinton was going to win, and he said, no, actually it's a tight election, there's lots of uncertainty in the data, we think it's probable that she'll win, but we can't be sure. And that is, people are not very good at thinking other than 0, 1 or 50-50, like they it will happen, won't happen, might happen, but there are and there should be shades of subjective probability in which we say, I think this is likely, but it might not, and that's what Silver was doing, and I think that's a very healthy way of thinking about the world.
So you have a whole chapter on our brains as Bayesian calculators, as it were. But why is it that people tend to think black and white and true or false in binary ways?
Honestly, I don't know. I think it is computationally difficult, or sort of cognitively difficult, to keep the if you went around thinking it's like 95% likely, if you did the conscious maths in your brain, that would get overwhelming quite quickly. And I would be speculating for what it is about our brains that sort of says that we sort of fall so neatly into is true, isn't true. But I think, to speculate, I think it's sort of comforting. It allows you to sort of agree with people in a sort of tribal sort of way. We all agree on this thing. We all disagree. These things are good, these things are bad. And if you are doing, if you're saying, I think this thing we all agree on is only 75% likely, then you're sort of signaling, I think you guys might be wrong. So I wonder if that's part of it, but it's pure speculation. Yeah,
we do tend to think in binary ways. It could just be part of our evolved cognition, maybe. You have that section discussing what is a game, kind of Wittgensteinian, family resemblance of things. What is a heap? If you have 1,000 grains of sand, that's a heap. How about 999? No, yeah, that's a heap. How about one?
Yeah.
No, that's not it. Yeah. So, but you just have to draw the line somewhere. And, this is what confuses people, I think, on the abortion issue. The pro-lifers are saying, well, we draw the line here, and that's the definitive place. Well, why not here? And, is it the 6 weeks or 12 weeks or 15 weeks? And the problem is that there is no place where it's obviously where the lights come on and there's cognition or perception of pain or whatever it would be as your criteria. And no one agrees on the criteria exactly. So you end up with these kind of fuzzy borders of where to draw the line, but you have to draw the line somewhere legally.
Yeah.
Right. What is the legal age for drinking or driving? Well, it's not like, the day you turn 18, you're somehow different than when you were the day before when you were 17. It's just that's the problem there.
Yeah, no, it is. It's a consistent problem throughout any situation where you have to draw, like for example, diagnoses of mental health conditions. Like if you score 34 on this depression questionnaire, you're healthy. If you score 35, you've got depression. It's not how it works, right? But we do have to somewhat arbitrarily draw a line for the, for the purposes of sort of record keeping and law. But that doesn't mean we have to think like that. We don't like what Bayes tells us about exactly the paradox of the heap is, if there's 1,000 grains in the heap, we can have a very confident prediction that most people will call that a heap, that I would consider that a heap. If it's got one, we have a very confident prediction that it wouldn't. And as you add or remove the grains, you can change your subjective probability estimate that this counts as a heap. And likewise, with an unborn fetus, you could say, at 1 day after conception, I'm extraordinarily confident that it is not a person. At 1 day before birth, I'm extraordinarily confident that it is, or pretty confident. Let's just say very, very confident. And that gets complicated quickly, doesn't it? But and in between, there's some line where it's ambiguous. And what percentage probability am I happy to put on that? And what percent? Same with drawing the line for, drinking and driving and everything like that. I'm broadly confident, not that confident, that most 25-year-olds are safe to drive. Not that confident at all, actually, now I say about that. And I'm very unconfident that, again, my kids at 8 and 10 are confident, are safe to drive. So at some point in between, we have to reach a probability estimate where we say that'll have to do. I can't that. And where we draw the line is always going to be arbitrary, but that doesn't mean we have to think in the arbitrary on-off terms when we're talking about individuals and thinking about individual cases.
Yeah. It's like the UN's definition of poor is $2.50 a day. But if you make $2.75 a day, it's not like you're not poor.
You're not rich suddenly.
Now I'm rich, or now I'm okay. Yeah, that's the problem. Okay, so who was Reverend Bayes, and what problem was he trying to solve in developing this equation?
Well, so there'd been, by the time Bayes was born in 1701, I think 1700 or 1701. We don't actually know when he was born, but with probability about 0.8, he was born in 1700.
That's funny.
That people have been trying to solve. Well, people have sort of been studying probability for about 100 or so years, and some of the people who made the first breakthroughs were like Blaise Pascal, and Pierre de Fermat, Fermat of last theorem fame, and they were sort of asking questions like, the classic one was the problem of the points. How do you imagine you're playing some game of chance and one of you's in the lead, but then you have to quit the game halfway through because the police raid your gambling house or whatever. If you say you're 2-1 up in a first to 3 game, what's the fair way to split the pot? And they realize that it's to do with how many outcomes remain. So if it's 2-1 up, there are 4 possible outcomes. 3 of them the player who's ahead wins. So the fair way to split the pot is 3-1, and that is sort of that, and that sort of started the idea of probability theory in general. But what that was all about was how likely am I to see some outcome, like this guy winning, given some state of the world, some hypothesis, like we are playing this game. What statisticians and what scientists in general want, I think, I think most of us would certainly think this, is that when what they want to say is, how likely is it that my hypothesis is true, given some experimental result? If I do a COVID vaccine trial and I get 10 cases of COVID in the placebo arm and only 1 in the vaccine in the vaccine arm, what does that say? What can I say about my hypothesis given that? And what Bayes did, so the Reverend Thomas Bayes, who was a nonconformist minister in a little town not that far from London called Tunbridge Wells in the mid-18th century, what he realised was that you have to take into account what you believed before. It's quite a profound philosophical point that he realised that probability is not some fact about the world. It's your own estimate. It's a statement about your own ignorance, really. Like you're saying, I don't know what, before I did this experiment, I had this best guess of how likely my COVID vaccine was to work, and now I have this evidence. It updates my guess with new information, and I improve it. And that was Bayes's sort of great insight, and it's complicated because it makes a lot of people uncomfortable because it makes it subjective and squishy. People sort of want science to be rigidly objective, and these numbers tell us these things. But in the end, it can't be. There is always going to be personal judgment and estimation. A sort of art to it of how best we guess these things, and So that created the great fundamental split in statistics that lasts to this day between frequentists, people who study who treat statistics as sort of in the how likely am I to see these results given a hypothesis way, which doesn't tell you how likely your hypothesis is to be true. And then there's the Bayesians who say, how likely is my hypothesis to be true given this result? But it is always going to be at least partially subjective.
Yeah. So all of this is a fact that of our lack of knowledge, our fallibility, that I'm not God and neither are you. I tried this at a recent God debate I did, where I said, you think there's a God, I think there's probably not. But one thing I know for sure is I'm not God and neither are you. And they're like, yeah, that's right. I'm like, okay, so that means you don't know. You're not omniscient. You don't know for sure. I just tried to put a little, a bit of doubt in there. All right. So I brought your experiment in the book. You asked readers to flip a coin. All right. So is an 1884 silver dollar with the eagle on the back and the whoever she is on the front there. All right. So here we go. I'll do it as you instructed in the book. Place it, thumb and forefinger here.
Yep.
Here we go. And boom, like this. Okay, nice. It's on the back of my hand now.
Coolly done.
Okay, now, so then I use this as a demo in my class. So what are the odds it's a heads? And they go, well, it's 50%, right?
Yeah.
But how could it be 50%? I've already flipped the coin.
Yeah, it's true or it's false.
Right. So that's your point. All right, let's see what it is. All right, it's heads. Okay.
Good stuff.
So what's your point in that exercise?
Well, my point in that exercise is that to demonstrate that for most of us, at least, probability is subjective. It is like, yes, there's a fact of the matter about whether or not the coin has landed heads up, but from to us, it remains just as uncertain as it did before you flipped the coin. And even if you had looked at the coin and then hidden it up and you knew the answer, to me, it would still be, I don't know. My probability estimate is a statement of my uncertainty about the world. It is not. And when we say it is 50% likely that a coin will come down heads, we're not making some metaphysical claim about the nature of coins. There's not something, there's not some property of the coin that there's magically 50-50. It is just a question of, if I flip, I don't know how many times it'll flip over, how much energy you put into the flip. I don't know how many times, what the air resistance is like. So I cannot predict which way it'll come down better than 50-50. So I just have to say 50-50. It is a statement about my ignorance. And I think that is I think most people would intuitively agree with that. I think, but that is not what Bayesian statistics teaches us. Whereas frequentists would, I don't want to straw man them here, but I think this sort of the heart of frequentism is that that there is a sort of fundamentally, if you flip a coin 1 million times, it will come back roughly 500,000 times, and that's just sort of a statement about the coin. Whereas for Bayesians, it's a statement about our own ignorance.
Yeah. James Randi used to do a magic trick in which he had these 4 big envelopes with cards, playing cards in them, just big ones. And then he did his whole thing set up. Okay, pick one, anyone. And then he seals them up in there and he's blindfolded and the whole thing can't see. And then he lays them out there and then asks the audience, all right, what are the odds I'm going to get this one? They're doing their calculations and all this stuff based on the setup. And then the denouement there is, he says, no, it's none of those. It's 100% that I will get it. It's a magic trick.
Yeah. Yeah. Exactly. So that's the sort of line I use in the book. I think is that if you say what's the odds that it's 50-50, and I'm pretty sure you're an honest guy and not trying to trick me and it's not like some stunt, I'll probably say 50-50. But if I know that you're a stage magician, or if I know that you're the owner of the world's largest collection of double-headed coins, I'll say something different, right? It's not. Yeah. It is absolutely my statement of whether it is 50-50 is reliant on my prior probability that the coin is fair, that you aren't cheating me, that it is. That I've correctly judged the situation we're in,
So that would be one of my priors, is that normally I would say X, but because I know this guy's a magician, I'm going to take that into account of what my answer is going to be.
Yeah, exactly. Like if a guy goes and smashes my watch in a bag, like if it was just some guy in the street, I'd be a bit, well, you've just, my prior probability is my watch is going to be smashed. But if it's James Randi or Daniel Dennett doing a trick or something like that, then I will. So, well, no, there's probably some trick here that I'm not getting.
Yeah. Okay, let's walk us through the equation. Here it is on the cover.
All right. Okay. The probability. This is a trial. All right. Probability of A given B equals the probability of B given A plus the probability of A. No, times the probability of A divided by the probability of B. It just tells you everything you need to know, right? We can all go home now. Yeah.
Okay. How would I actually do a calculation like that?
Okay. So imagine that you had. I'm going to do this without anything written down in front of me, so forgive me if I get it wrong. But imagine you had some test, like let's say it's a medical test in which I
have it here in front of me. If you'd like me to read it, and then you can.
Do you want to do it?
Yeah.
I was going to try and ad lib it and get it terribly wrong. Do you want to give me the example?
That's. I know. I've tried to do that before, and I always screwed up.
Yeah. This is safer.
Okay. You go to the doctor. You're not feeling well. They give you some tests. They tell you that this disease happens in 1 out of 100 people, or a 1% prevalence rate. The test sensitivity for this type of cancer is 90%. That is, the test will be right 90% of the time. The false positive rate of the test is 9%. That is, the test will be wrong 9% of the time. What is the percent likelihood that you have cancer? When people are presented with this problem, the most common answer given is between 80 and 90%. The correct answer is 9%.
Yeah.
The problem is so counterintuitive that not only do most people get it wrong, most medical professionals get it wrong. And so here's the calculation. In a sample size of 1,000 people, 10 have cancer. That's the base rate of 1%. Of these 10 people, 9 will test positive. That's the 90% sensitivity of the test. Of the 990 people without cancer, 89 will test positive. That's the 9% false positive rate. A person tests positive. Does this person have cancer or not? So then you do the calculation. Out of 1,000 people tested for cancer, 98 of them test positive in all. That's 9 plus 89. 9 of them have cancer, so 9 divided by 98 is 0.91 or 9%. Anyway, that's the calculation. And most people get that wrong. Why? Because they neglect that false positive rate tested on the huge population.
Yeah. Well, they fail to take into account the background rate. It's like Daniel Kahneman and that called it base rate neglect, didn't they? They just sort of failed to take into account the information you should have already had. I tell you what, I was trying to think of ways of making it more intuitive the other day, and the way I thought, like, imagine I did a test and it's 99% specific, 99% sensitive, so only gives a false positive 1 time in 100 when someone has the disease, the condition. It only gives a false negative when someone doesn't have the condition, does have the condition 1 time in 100. Yeah, so it'll give the right answer to that person 99 times in 100. I take the test and I get a positive result. What are the odds of me having this condition? And most people will go, well, 99%. But what if it was a pregnancy test? And I go, well,
right.
Yeah, well, oh, right, okay, yeah. Because imagine you gave this test to 100 people, 100 men, it will return 90, and it gets it wrong 1 time in 100. It'll return probably 99 true negatives and 1 false positive. And so the odds of me having pregnancy, being pregnant, are damn close to 0. Because I'm quite old now. Okay.
Yeah.
But you know what I mean. So I think that's an intuitive way. When people realize, oh, okay, yeah, that of course there are ways of we need to take into account these background rates, and then you can use that to think. Well, now think about if there was a rare cancer, or if you did a COVID test before, in January 2019, before COVID was a thing, and your COVID test turned up a positive result. That can't be right, Whereas if you did the same one in April 2020, things would be very different,
Right. So, that base rate. So by that example, let's say you have a 1% false positive rate. But if you test 1 million people, that's 10,000 false positives. And so when the numbers are large, then it's not that unlikely that somebody who you think has it actually doesn't have it.
Yeah.
Because they could be one of those 10,000. That's a lot.
Yeah, exactly.
Right. All right. So, base rate neglect, I think, is a huge one. Kahneman and Tversky also talk about the cognitive heuristics that interfere with this, the famous Linda I'm trying to remember. Did you present the Linda problem in your book?
About the feminist bank
Yeah,
teller.
that's right.
Yeah.
Yes, the feminist bank teller. Yeah, go ahead and give us that as example. What's the problem there?
Yeah, so, I mean, what that is, you ask someone, I'll tell you, I'll bring it up in front of me so I can get the... feminist teller... Anyway, yeah. So I can't find it quickly in the thing, so I'll wing it. But the basic idea is, if you ask people that they describe a person, for example, Linda is active in women's politics. She wears dungarees or whatever. There's some very stereotypical image of a woman. This was the 1970s, so this isn't my language. And then they say, what's more likely, that Linda is a bank teller, or that Linda is a feminist bank teller? And people would, given the two things separately, that people will tend to judge that it is more likely that Linda is a feminist bank teller than that she is just a bank teller, even though by definition the set of people who are feminist bank tellers must be smaller than the set of people who are bank tellers. It must be true, but because people fail to take into account, because they use the heuristic of, this sort of fits my narrative, this fits the story, and there's a lot of this. People, you do the same with, if you ask people what's more likely, that Bjorn Borg loses the first set, or Bjorn Borg loses the first set but then wins the match, they say that they tend to rate the second one as more likely, even though you can't you can't lose the first set and win the match without first losing the first set. So people don't think in these terms of sort of of what the base rates and frequency and probability. They just sort of, this fits the narrative better. The story makes more sense in my head, so I rate that as more likely. I think that's what's going on there.
Yeah. I think Tetlock touched on this with his forecasting failures. Is that if you ask somebody what's the probability of Kim Jong-un launching a nuclear missile against Hawaii, or Kim Jong-un launching a missile against Hawaii when the United States imposes economic sanctions, and then this happens, and then that happens. And the story, the more details, the more likely it seems in people's minds, even though each detail you add makes it less likely to happen than the general one. Yeah,
absolutely. And I mean, it is because we are, it's such a cliched thing to say, but we're very narrative, very sort of story-based creatures. And that just sort of sounds like it's more narratively satisfying to say those things, rather than this somewhat sort of backwards sounding thing happened. There was then another example where you do the same question is people would rate it more likely that Reagan will provide federal support for unwed mothers and cut federal support for local governments. They found that more likely than Reagan will provide federal support for unwed mothers, even though again that first must be more likely than the second, because it's a larger set of situations. So it is funny how people's brains work, but these are well replicated findings over years.
Yeah, that not only that, but also they call it the conjunction fallacy. Just doing the statistical calculation. So I use this to counter the 9/11 truthers, because they believe that not only did the planes hit the buildings, but that also explosive devices were used, planted in the buildings to bring them down. Well, the one can't be the first scenario where both things happen can't be more likely than just that the planes hit the building.
Yeah.
Not to mention, they'd have to somehow get in the World Trade Center buildings without anybody noticing to plant the bombs and all that stuff. And they would have had to plant the explosive devices in exactly the same floors where the planes hit, because that's where the collapse of the building started, and so on. But that's all you have to know is the conjunction fallacy, that they can't both be true. Although I should point out that among 9/11 truthers, there are a small subset of no planers. There were no planes.
Wow.
Those were CGI videos. Yeah.
I hadn't heard that one.
It's kind of fun to see the 9/11 regular truthers debating the no planers, right? So they each have their own line of demarcation. Now that is crazy. No planes. Of course there were planes, but they were remote controlled planes or something like this.
Yeah, that's brilliant.
It's totally crazy.
It's funny. I don't know if you got to this bit in the book, but I feel like there's the Bayesian Bayes theorem has something to say about conspiracy theory beliefs, because like to you or me, the evidence that would suggest, like, but this doesn't make sense. The evidence, like, how can you that there weren't any bombs in the building? How, like, there's all this evidence just pointing us this way and that. But the thing about Bayes' theorem is that you need to put your probability on some hypothesis, right? And new evidence comes in, shifts your probability mass around, or the probability you put on things. And if, for example, you're someone who believes that vaccines don't cause autism, or they'll believe it's a vaccine, then the evidence comes in and says that they don't cause autism, that's fine. But whereas if you're someone who believes it very strongly, then evidence comes in, the BBC tells you or something that scientific papers have found that vaccines don't cause autism. It could move you to believe that that vaccines don't cause autism, or you've got an alternative hypothesis, which is that the BBC and the the scientific community are lying to you, and you can move so there's an alternative hypothesis where you can move your probability to, and that explains, I think, quite neatly in a sort of like how it is possible for people who are who might not be stupid, right? They're not like they're not like aliens with different brains to us. They're people like us with the same sort of not broadly the same sort of capacity for finding stuff out as anybody else, but because they have these strong prior beliefs, it means that their belief in their evidence shifts their beliefs in different ways to us, and that makes and in a way that's the rational thing for them to do given the state of their prior beliefs, and that I find is both sort of, in a way, it's heartening because it means people are just people. We don't have to posit that some group of people among us are aliens with weird brains who don't think like us. But it also makes it hard. How do you talk them out of these false beliefs if, to some extent, they're acting rationally given them? That was an interesting bit of the book I found, and I hope I've done it justice.
I loved all that. No, I love that. You did. Conspiracy theories are a topic we cover a lot, and the problem. So take that example, that vaccines cause autism. That's been around since the 90s when Andrew Wakefield published that paper in the Lancet that was subsequently withdrawn and declared fraudulent and so on. And yet still people are hanging on to it. It's got a little bit of resurgence with RFK Jr. Yeah. Kind of beating that bush again, not just on vaccines and autism, but vaccines and everything.
Yeah.
And I don't know how you run a presidential campaign on this one cause, but in any case, that's what we've been hearing about. So people's priors in this case, if it's parents that have autistic children, and they think back, what's the thing I did unusual just before my kid was diagnosed? Oh, yeah, we got those vaccines, right? So you have this kind of correlation, causation assumption. And then that anecdote stands out, and then the word spreads through communities of autistic parents. That's how that started. And then someone like Wakefield comes along and they go, oh, yeah, now we have our evidence. Then why don't they adjust their priors when new evidence comes in? Like, oh, that study was fraudulent. It was withdrawn. Not a single other study has found a connection between vaccines and autism. And still they hang on to those priors rather than adjusting them. Yeah,
I mean, and it is because if the only two hypotheses available were, like heads or tails on a coin, if it was either it is vaccines cause autism, or vaccine or the scientific community is right and they don't, and the more evidence comes in, the more papers come in, then there'll be nowhere else to move your probability. You've got something has to happen. Something has to be true. There's 100% of probability mass to go around, and you either have, if you have 99% of it on vaccines cause autism, and then new evidence comes in, and you can shift more and more of it to the vaccines don't cause autism thing. But if there's always other hypotheses, other places you can shift things, and one hypothesis would be vaccines do cause autism, but the scientific community is lying to me. And if you have this very strong belief, then your hypothesis, it is very hard to shift those sort of really strong priors with evidence. And so things like people saying the scientific evidence shows something else, you stop trusting them. And again, it is sort of tragic in a way, because it means that it is rational in some strict sense to not believe, to update the beliefs the way they do. And that is sad and difficult. But I suppose what it means is that for those of us who would like people to believe what we would, I guess you and I would both think is the true thing here, which is that vaccines don't cause autism and do protect people from various diseases, we have to work on improving people's trust in scientific literature rather than just sort of hammering them with, look, here's what the science shows, here's what the science shows. They don't trust that. Have to work on ways of boosting that.
Yeah. So in that case, their deeper prior is somewhere else. It has something to do with an underlying larger structure of some kind that they don't trust. It's like that. My favorite paper in the conspiracy cognition literature was called Dead and Alive. That is, people that tick the box that they think Princess Diana was murdered are also more likely to tick the box that says she faked her death. Well, she can't be both dead and alive.
That's lovely.
And these aren't idiots that are ticking these boxes. These are just regular people. What's going on? Well, the researchers concluded that it was a deeper distrust of authorities of any kind. So whatever the government tells me, I'm just not going to believe it. They tell me she was, she died of drunk driving. I don't believe it. Well, she must. So anything that somebody says, if it goes against what the authorities say, then I'm going to believe it, even if they're contradictory. And I think that goes a long ways to explaining it. And that's what happened after COVID, right? Because all the dumb mistakes that the scientific authorities made, like closing schools, closing beaches and hiking trails. I mean, this is just insane. And but then they go, okay, but the vaccines are good. And so the average consumer of content here is like, well, why would I trust them on the vaccine stuff when they said this other crazy stuff about closing the beaches?
Yeah, I mean, the thing here in particular was the massive 180 on masks don't work. Masks might actually, the public health authorities saying masks might actually make COVID, you're more likely to get COVID because of risk compensation. 180 a few months later to actually, we all need to wear masks everywhere you go now. And that is, people don't forget this stuff and they do find it complicated. And on the closing stuff out, like children's play parks were closed around ours. It was like around a lot around, and there's still like basketball hoops missing from local playgrounds because they were taken down. Why would you take down a basketball hoop? Do you think people are getting COVID while playing basketball? And it's obviously just make kids more bored. It was like they're like, well, if anyone's having fun, that might give them COVID. It was tragic. It was really sad.
Yes. Yeah. So I guess that then how do we get people to trust the overall structure as being relatively trustworthy, and therefore the information they send us can be adjust our priors and adjust our credences and so on. Okay, I want to talk about the kind of the nature of science here.
Yeah, please do.
By reading a quote from Richard Feynman. I use this quote. There's an actual YouTube video of him at Cornell University in 1964. It's very amusing. He says, if it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make any difference how beautiful your guess is, how smart you are, who made the guess, or what his name is. If it disagrees with the experiment, it's wrong. That's all there is to it. It's such a great point because he makes it so poignant. And it's Feynman making the point. But, when I think about it, because you use a similar example in your book about, well, if it's Einstein who says it, I am going to pay attention to it as opposed to John Q. Nobody.
Yeah, I think that's true. I mean, so, yes, if it disagrees with experiment, it is less likely to be true. And I would agree with him completely. Absolutely. But we all know experimentalists, they don't get everything right. Like, not every experiment that comes back is like the replication crisis in science should have taught us something really dramatic, which is that a lot of scientific experiments are, I don't want to say fake, but they're kind of fake. Like there's a lot of scientific
sloppy.
Yeah, sloppy. They're not in it. There's some either they're badly done or they're done for, so scientists have other incentives than finding out the truth. They want to get tenure, they want to feed their children, they want, and scientific journals publish results that are interesting and novel rather than results which are necessarily true, so they tend to fill up. So on the one hand, the journals tend to fill up with the papers which find something, which whether or not it is really there, and scientists are incentivized to publish papers which find something, whether or not there's something really there, and that means that you end up with a scientific literature which disproportionately fills up with, if someone there's 100 people do scientific experiments into whether or not psychic ability exists, and 99 of them don't find anything, and only one does because of fluke, and then that one is the only one that gets published, then the scientific literature looks like psychic abilities are real. But that's not true. So yeah, so I think Feynman was well, he was a physicist, and physicists have it much easier. Psychologists, they can get millions of data points. They can run huge machines that fire trillions of lead ions at each other until you've got more data than you can shake a stick at. Psychologists have to work with 17 undergraduates from the University of Ohio. It's not the same thing.
Right.
But it is nonetheless true that if a lot of theories, like Einstein, the example you give, right? His theory of relativity, the maths did fit beautifully together. And then when Eddington went off to measure he went off to do to look at the eclipse. Yeah, and to see whether, as Einstein's theory predicted, the weight of the gravitational mass of the sun distorted the light coming from the stars and would have shifted the position of stars behind the sun. That was, it's a brilliant experiment to test but if Eddington had come back with null results on that, I still would have been if I was Einstein, I'd have still been pretty confident that my experiment was right and that there was some sort of measurement error, or that my theory was right and there's some sort of measurement error, because experiments are noisy and mistakes are made, whereas the theory is really solid. And so I can sympathize with a sort of a different position to the Feynman one, which is actually sometimes experiment is wrong and theory is right.
Yeah. Well, in that particular case, historians of science have kind of teased out what actually happened in that case. Eddington's eclipse team found evidence more in support of Einstein, but there was a second eclipse team. And part of the problem was it was a little overcast and cloudy, and it wasn't clear how good the data was, particularly on the second team, whose data slightly supported Newton's. Newton had a theory that it would bend light, just not as much as Einstein said it would bend. And so it kind of came down to the scientific community in these journals about what they were going to emphasize, which team's data they were going to emphasize over the other ones. And they emphasized the Eddington data more than the other eclipse team data because it fit Einstein better. Now, it turned out Einstein was right, and lots of tests since then have confirmed that.
Yeah.
But again, it shows you the kind of the cultural nature of science. And, we do have our preferences. And, Einstein's theory was just so beautiful, whatever that means in mathematics, because I don't do that. But, again, Feynman's right. In the long run, you have to have the data on your side. Your name will only get you so far. My favorite example of this is a guy named Thomas Gold. He was an astronomer at Cornell University and made a lot of accurate predictions in his career. Very, very great scientist. He accurately predicted the thickness of the moon dust when the Apollo landed there, Apollo 11. And, that was super cool. Anyway, so he had this stellar career. And late in his life, he published a book, I think it was late 1990s, called The Depot Biosphere. And his theory was that oil is not a fossil fuel. It's not. You guys are all wrong about that. It's a byproduct of this depot biosphere. That is these microscopic organisms that live in rocks. That part's true. And they secrete some kind of substance or whatever that keeps filling up these oil reserves. The problem was, how come, peak oil was supposed to peak in the late 60s and then 70s and then 80s and 90s, and these oil companies keep pumping it out. And he said it's because they're getting refilled by this depot biosphere. Okay, well, I remember when this book came out, it was published by a major New York publishing house. It got press and reviews everywhere. But I think only because it was Thomas Gold. If it was just some whack job saying, hey, I have a theory, oh, yeah. And, because it was him, the geologists felt the need to say, no, okay, here's how we know oil is a fossil fuel. Here's our 6 lines of evidence. And everybody walked it through. And then it's like, oh, okay, there's probably nothing to this. And within about 6 weeks or so, the whole thing was gone.
Yeah.
Right.
Yeah, I mean, another of my priors, you might say, is that physicists in particular go through a sort of late career crank stage quite often, don't they? Physicists age about 75, let's go into a different, how hard can it be? I'll go and study, I don't know, epidemiology.
Archaeology
yeah,
or something.
Exactly. I can solve this. All you need is a few terms in the equation. I'm sure we can fix it. There's generally something a bit more complicated going on, and maybe, they stick to physics.
Yeah.
But
that's a great example. Yeah, there was a guy from Harvard, I think he was a marine biologist. Barry Fell was his name. Anyway, late in his life, he decided he was going to take on archaeology, about who really first populated the Americas.
Yeah.
And, he had in his head a line of evidence, and, he just is not an archaeologist. And, there is something to be said for expertise and background in an area.
Yeah, domain knowledge is a thing. I mean, also this is where it's so complicated, right? Because there is also something to be said for not trusting, nullius and verba and all that. And a lot of we know that a lot of the a lot of the stuff I write about and talk about, I've got a podcast of my own sometimes, and we talk about the evidence for various things, and like we're doing, the loneliness epidemic is something we're talking about recently, and actually it gets talked about confidently by people who are experts in these things, but I don't think, I've looked at the evidence and I don't think it's there that when people say, that loneliness firstly is rapidly increasing, and secondly that it's as bad for you as smoking 15 cigarettes a day is the claim put around. I'm very confident that neither of those things are true, because I can look at the evidence myself and not take it on trust from an authority figure. But on the other hand, if I do that too often, I'm going to get things wrong and be, so you need to be, it's this weird tightrope walk between not assuming that you can just blunder into any old field and to get it right where the experts haven't, but also not just taking things on trust because they are said by experts, and being willing to go and look at the evidence and then saying, okay, in this case I'm pretty confident that I can't do better, or in this case I think there's stuff being missed. It is there is no simple answer to this for how to be as right as you can be, is there?
Yeah, that's right. Sometimes outsiders do make contributions to fields, but usually not. And, the Galileos of the world are very, rare.
Yeah,
we stood up to the church. Look what happened.
Yeah.
Well, what was somebody used? It might have been Asimov. They laughed at the Wright brothers. Well, they laughed at the Marx brothers.
Yeah.
Being laughed at doesn't make you right.
Yeah, it was Sagan said something very similar. They laughed at the Wright brothers. They also laughed at Bozo the Clown.
Oh, yes.
Yeah. So I wonder if it's a good line. Could have been several people saying it.
So Sagan's principle is it's called the ECRI principle. Extraordinary claims require extraordinary evidence. That's a Bayesian way of thinking, right?
Absolutely. If you've got very low prior, well, it's literally Bayes. Yeah. If you've got very low prior evidence prior confidence in something, very prior belief in something, it will take a lot of very good evidence to shift your beliefs to something else. If someone told me that they had seen a fox in the street outside my house, I would say, okay, fine. I'm very happy to believe that. I'm not going to argue. If someone said that they had seen a leopard in my London street, I would assume they were joking or mad. I would take an awful lot of it. Even if they showed me a photo, I would probably not. I would assume it was faked, or it was, that it was somehow just something had gone wrong with the camera. That it was like actually a house cat that had looked particularly large in the light. Because I have these strong priors that there aren't any leopards in Crouch End, right? And so absolutely. If someone were to say to me, this person came back from the dead, or aliens have landed, and even if they had evidence that in other situations I would be very happy to believe or very happy to accept, I would need far more to convince me of something extraordinary. I mean, that's funnily enough, this is possibly ironically, this is sort of how the whole Bayes theorem paper got published in the first place, because it was written by the Reverend Thomas Bayes, the aforementioned Presbyterian minister, but it was published after Bayes' death by this guy Richard Price, who, by the way, is a really cool character. He was for American listeners, which I assume is most of you. He was friends with Ben Franklin, friends with Thomas Jefferson, friends with I think it was Thomas Jefferson and John Adams. And he was also, he wrote a pamphlet in early 1776, which was hugely popular and reprinted. Had some name about on the conditions of liberty and the American Revolution or something like that, and it was very influential in leading to the Declaration of Independence. Really, like a cool guy. It's surprising to me. I mean, maybe it's just that I hadn't heard of him very much, but apart from as the Bayes publisher, but I don't think he's very widely known nowadays, and I think that's a bit of a shame. But he published Bayes' Bayes theorem as the paper in the Royal Philosophical Transactions of the Royal Society, and sort of why he did it was to defend exactly against this David Hume, who sort of said extraordinary claims require extraordinary evidence. He didn't say it in those words, but he said, if you tell me that someone's come back from the dead, there's a miracle has occurred, for me to believe it, it needs to be more miraculous that the person who was telling me was lying than it would be that the actual thing happened. So it's almost no way I will believe you if you tell me someone came back from the dead. I'll just think it's more likely that you're lying. And That is somewhat Bayesian, although it is very Bayesian, but although you should shift your belief a bit, I guess, But what Price's thing was, he's saying, no, off the back of Bayes' theorem, which sort of bakes in a little bit of uncertainty into every situation, but the Cromwell's rule of Bayes' theorem is, in the bowels of Christ, I beseech you, think it possible you may be mistaken. So just always think it's possible that there is that you've got it wrong. And what Price was saying is that no matter how many times you see people not come back from the dead, you can't be sure that they never will. We can't rule out the miraculous. Now, I funnily enough, I think he sort of drew the wrong lesson from that. There's a bit of wishful thinking. I think actually you're right. You can never be certain, but never being certain is not the same as not having confidence, or not. It doesn't mean all is equal. And so I think you can. The fact that you've never seen people come back from the dead does mean that you should downweight the probability of it very significantly. And I also think that, we should have sufficient confidence that if someone came up to you and said, or a book which you read said, someone came back from the dead 2,000 years ago, I think that should be very weak evidence and should only make you update a very small amount. But that wasn't the lesson that Price took. Price wanted to say this is the Bayes' theorem allows me to defend against David Hume's attack on God, which it's quite a high, it had grand ambitions right from the beginning. I quite like that. Yeah,
no, that's a great story. And, much has been written about Hume's treatise on miracles. Is it just a one-off, highly, highly unlikely, but not statistically impossible event? Or does there need to be divine intervention to make it happen, which would make it a religious miracle, rather than just a highly improbable event, like things you hear about? Like, what was it? Anthony Hopkins was scheduled to be in this film, and he went to get a copy of the book that it was based on, and the bookseller was out of it, and he walks down the street, goes to a Subway, and there on the bench is that book.
That is weird.
Yeah. And it's even weirder than that. It turned out it was the copy that the producer had lost, the director had lost, and had handwritten notes in it. I mean, just one of these, million to one, billion to one type odds.
Tell you what, I'll see if this story comes across. I hope it's not too long, but it was the weirdest coincidence I ever had, which was, there's another author called Tom Chivers, right, in the UK. We've sort of always get each other's emails, and people like he's a poet. Funny. Yeah. So anyway, but I remember I was in I was miles from home in a totally different bit of London, with my kids, and there was a coffee shop where you have to give your name at the coffee shop, I said, I can have a Americano, please, and the woman behind the counter said, what's your name? And it's Tom. And she said, can I get your surname? Because the last guy was called Tom as well. And I said, it's Chivers.
Oh, no.
And the guy behind me piped up and said, do you know my surname? And she said, no, it's all right. He's Chivers. And I said, and he went, it's Chivers as well. And it turned out that this was the other Tom Chivers, and that we which we would never have known. We'd have walked past each other if we hadn't happened to be standing there at the one moment where we had to say our names out loud. And it really struck me as it really threw me. But one time in a billion to one chance comes up, right? Then that's just how statistics works.
Yeah.
It really threw me. I still think about that sometimes. Going, oh,
well, so there, in terms of a Bayesian calculation, you're not getting into the equation all the things that could have happened that didn't happen, also by chance. So I wrote about this a little bit in my truth book coming out here on this example of from Martin Gardner, the late science writer, mathematical games columnist. Martin. Yeah. One day he was pursuing a used bookstore when he came across a familiar title. His father had given him a copy of that book when he was a child, but he lost it during a move many years prior. He considered purchasing this replacement copy. As he considered purchasing, he flipped through the pages and found his own handwriting in the margins. It was the very book that Gardner had lost. And then I tell the Anthony Hopkins story. In 1972, he was signed to star in the film adaptation of George Pfeiffer's novel, The Girl from Petrovka. Hopkins went to several London booksellers to purchase a copy, but none had it in stock. Heading for home at the Leicester Square.
Leicester Square.
Thank you. Tube station. He chanced upon a book on a bench. Unbelievably, it was The Girl from Petrovka. 2 years later, when Hopkins met Pfeiffer and mentioned the coincidence to him, the author noted that he had lent his copy to a friend and handwritten edits in it for the American edition, changing labor, L-A-B-O-U-R, to labor, L-A-B-O-R. For example, when Hopkins flipped open his copy, he saw Pfeiffer's hand annotations. It was the very same book.
That is bonkers.
That is totally bonkers. Yeah. So the statisticians who write about this stuff say, well, if you have a 1,000,000,000 to 1 odds or whatever, but you have 1 billion people, you have 8 billion people now, whatever, and all the billions of trillions of things that could happen, also by chance, but they don't, or they do and you don't notice them or whatever. And so you get the sum of all coincidences is certainty. It's just that's just the way the world works.
Yeah.
In the case of miracles, you see, there's an addition people have made to the Hume argument, that it's not just a statistically unlikely, because you guys could counter with law of large numbers, but that it's an intervention by the deity. Yeah. So then I guess I would say, well, how do you know that it's because the Holy Book says so. Well, how do you know the Holy Book is correct? And then I'll counter with examples like Satya Sai Baba in India, the fakir who claims he could raise people from the dead and bring seeds to life in his palm. These are all magic tricks. And I've seen Penn and Teller turn water into wine and walk on water. Teller has this little clear plastic platform that's like an inch below the water level, and it's all set up ahead of time, and he walks on water. But to the believer, I'm treating these as an empirical claim. And I think a lot of religious beliefs are not on that level. They're like, well, I don't mean it literally. I mean it some other way, some kind of internal, mythical or psychological truth, something like that.
Yeah. It is complicated because, again, it's a Bayesian thing though, isn't it? Like I'm exactly the same when we talk about cold reading and things. When someone says they can commune with the dead, and I said, okay, I said, well, okay, but I've seen people who are actively telling me they are faking do the same thing just as convincingly. So why should I believe you, you have a financial interest, let's face it, in convincing these old people, or vulnerable people, to tell them that their long lost granny is happy in the afterlife, whatever. But for me, therefore, my prior is extremely low. That you need to do some fantastically strong evidence to convince me otherwise. And most of the evidence that you could that you could show me would just convince me more and more this guy's a fraud. But for other people whose prior is that this stuff is plausible, there is a spiritual world where we can communicate with it, and they don't find that implausible to begin with. It takes much less evidence to convince them. But I agree with you that there is a sort of, to some extent, when people say that they believe that, I don't know, Jesus rose from the dead, or that or various other things, to some extent I think they are saying a literal belief, but to some extent also it's just signaling, this is my cohort, this is my group. I don't want to say tribe because that's sort of dismissive, but like these are my people, this is the group, and this is it's a marker of identity as much as it is a statement of factual belief. And I think you agree that you can't always treat it in exactly the same way as people saying. It's the same with like things like global warming, right? When people say, if you're a farmer in Kentucky or something like that, and you say, I don't believe in global warming, you are as much signaling a tribal thing as you are, because it doesn't. Your belief doesn't make any difference to the world, right? Like you won't behave. Whether you believe it or not won't affect how quickly the climate warms in any meaningful sense, but it will affect how you are treated by your friends down the bar later. So from a sort of incentives point of view, it makes more sense to believe the thing that the other people around you profess to believe. So beliefs have these beliefs aren't just about statements, about predictions about the world. They also perform social roles of signaling group membership and so on. And that's important. I don't want to belittle that because that's important, but it does mean it's complicated to treat them as truth-seeking things sometimes.
I think most of us can't fact check claims that are made. How would I know about climate experiments and computer modeling and all the math behind it? I don't understand it. I pretty much just trust that most of these climate scientists are competitive and they try to debunk each other and so on. And if I'm getting it, in third hand in a Scientific American type article, it's probably true by now. Maybe not. They could all be diluted or have a cabal against American business or whatever the conspiracy theory is. More likely they would just be all captured by a paradigm. but unlikely even that, Let me just give you an example of what I'm talking about here with these kind of mythic claims and stuff. So last summer I was in your neck of the woods at How the Light Gets In Festival in London.
Oh, cool.
Sponsored by the Institute of Art and Ideas. Anyway, so I was on this panel with psychologist John Vervaeke and philosopher Sophie Grace Chappelle. Anyway, they were into Wittgenstein, and they were debating whether we should follow the young Wittgenstein or the old Wittgenstein. And I'm not into any of this stuff, so I quoted Douglas Adams. Isn't it enough to see a garden is beautiful without having to believe that there are fairies at the bottom of it too? Anyway, in a write-up after this panel, the author says, this final argument from Shermer is typical anti-spiritual retort.
Ooh.
Show us the evidence, he says. Well, Michael, here it is. The mystical experience. The mystical experience, much like any other type of experience, offers clear evidence of spiritual reality. But what is the mystical experience? It is evidence of spiritual reality. Philosophical arguments for spirituality, or even for God, are far less value, in my estimation, when compared to the empirical evidence of the mystical experience. Spiritual reality can be well hidden when in a normal frame of mind, which is what I'm in, I guess.
Yeah.
Not much about regular reality hints at the presence of this possible radical other. But when you see it, when you have a mystical experience, the experience is undeniable. How should we think about that as evidence? I had this powerful experience.
I mean, honestly, I've had this conversation with people before, and I've got a good friend who I like very much, and she's a Christian, so I don't want to belittle her beliefs. But this, and what I would say to that is that can only be strong evidence for you, right? That I can never experience that evidence. So sure, it can change your beliefs, and I can take your word for it that you believe something more strongly now that you've had this profound experience. And I don't want to belittle that, but I don't know how from the outside or even from the inside, I don't know how you would distinguish that from a petit mal seizure, which gives you the same effects, right? And it sounds so belittling and so sort of like, well, actually, it's just your brain malfunctioning, whatever. And I don't want to say that, but from the outside, I have no way of telling the difference. And I feel that the crucial thing with evidence, if you want it to persuade people, the evidence needs to be, well, to some extent, for the evidence to be strong and to shift your Bayesian priors a long way, the evidence needs to be replicable and shareable. You could tell me that there was a fox in the front drive earlier today, and I don't need that to be replicated. It's fine. I will just take your word for it because I don't need much evidence to convince me of that. You had God spoke directly to you. I need more. It's not like saying there's a fox in the garden. It is saying there's something much deeper and much more like seems unlikely to me, and therefore I will need stronger evidence to have real impact on it. On my prior beliefs, and it's not. I'm not trying to be rude or critical or sort of like tell you that you are wrong for believing what you believe, but I am saying it doesn't shift my beliefs enough, and it never can. And I think even if I had that experience myself, unless it changed me really profoundly, like who I am as a person, which it might do because it's a thing that's happening in my brain, then I don't think it would. I wouldn't trust it because I would know from having read other things that sometimes people have temporal lobe seizures, whatever it is, and it creates this profound sense. Or people take magic mushrooms, and it creates this amazing sense of oneness and spiritual connection with the universe and the death of self and all that sort of stuff. And that's, I hope I've written about it in the past, so I hope, and my parents probably won't listen to this podcast anyway. So like I've taken magic mushrooms and I felt like that, and it's great. But that doesn't mean.
But you don't feel you went somewhere that is in some other realm that it's really out there.
No, it's just you change how neurotransmitters work in your brain. It gives you this incredible, profound feeling, and it stays with you for a few days afterwards. I remember this sort of like, oh God, I've seen insight, seen into the universe, whatever. But there's some bit of you, or there's some bit of me that goes, this is just, it's given me an interesting thing to think about, but it doesn't make me think that the world is, that I'm one with the universe in any more profound way than I was before. It doesn't make me think that there is consciousness or thought behind, and I don't think that any experience like that could make me more spirit, more but convinced of of supernatural beings or whatever, because I would know that that is the product of me changing chemistry in my brain rather than of that it can tell me stuff about what's going on outside my brain.
Yeah. Did you ever read Oliver Sacks' book Hallucinations?
I didn't. I read a couple of his. I read, obviously, A Man Who Mistook His Wife for a Hat, because everyone in the world has read that.
Same kind of thing, though. I mean, he writes about hallucinations that other people have, that he had when he was a medical student, pulling 80-hour, 100-hour work weeks and so on, and taking all kinds of meds to keep him up, and fantastic hallucinations. But he said, of course, in the end, I know it's just my brain. But most people that have these experiences, they sense it like out there, like the schizophrenic that hears voices. The voices to them are out there, not in there.
Yeah.
And Sachs makes the argument that if the brain scan experiments while the schizophrenic's hearing voices, their auditory track is active. The neural network for auditory information is active. So it works the same way as it does for you and I to them. So, of course, they would assume it's out there somewhere.
Yeah.
So I think that's part of the problem. You don't sense the brain operating at all. It doesn't feel pain. For thousands of years, people thought the thoughts were in the heart, not the brain. You can't tell. And so that's the problem. But not everybody. So Eben Alexander wrote that book, Proof of Heaven. That he went to heaven during this
like a near-death
coma
experience.
He was in. Near-death experience. And he's a Harvard-trained neurologist. So I was on a TV show with him, and we're in the green room, and I'm like, look, dude, you know more about the brain than I do. And I rattle off all the things, that it could have been. And you know all about hypoxia and this and that, neurotransmitter. He goes, yeah, I know. But this was unbelievable. You just had to experience it. I'm like, okay, dude, I know, but I didn't experience it. So, back to where you were, why should I believe it? I believe that you believe it.
Yeah. Yeah, I don't want to take away from it. Yeah, but also sometimes actually in my bitter little self, I do kind of want to take away. You should examine your beliefs a bit more here, I think.
Yes.
But then that feels very sort of actually, which but it does. I do think people should be more wary of their internal experience. Sometimes, it doesn't tell them everything. Funnily enough, the schizophrenic thing. It's again, at the end of the book, you may remember there's stuff about how our sort of conscious experience is just us predicting the world all the time, and then updating it with evidence from our senses. And there's some evidence or some possibility, a plausible hypothesis that schizophrenics are less good at predicting the world. Their predictions are less confident, so things like hallucinations or the auditory hallucinations are just them hearing their own thoughts, but not predicting them before they happen. So they sound to them as though they're an external thing, whereas we would just hear it as our internal monologue, And there was a brilliant experiment, which I would love someone to recreate, because I don't think it's ever been replicated, and I hate citing studies that have only got one, only been done once, and it wasn't a huge study. But I find it so sort of conceptually fascinating that the reason we can't tickle ourselves is that we can predict what the sensations will be very, very accurately. So, in order to tickle yourself, you need to have, in order to be tickled, the movements need to be unpredictable, and that schizophrenics are more likely to be able to tickle themselves than people who have not been diagnosed with schizophrenia. So I found that was a really interesting demonstration of how our brains.
I always thought that was control, that I'm controlling my movements, and somebody else I can't control. But the prediction thing makes more sense for why you can't tickle yourself.
Yeah, no, I like that, and but then control is all about prediction as well, right? Because you are predicting a set of nerve signals sent from my brain will have this particular effect on my fingers, and that will lead to this particular set of sensations. Your motor control is absolutely about predicting things. You need to predict what set of certain nerve signals will perform a certain action. You also need to predict what set of actions will come from a certain set of nerves firing. And that is when babies are very young, they do what's called motor babbling, which is basically moving at random and seeing. They have very low confidence predictions in what nerves do what. And so you see them sort of flailing around, legs twitching and all that sort of stuff. And as they get older, and you can see it happening, they get more confident. They call it discovering their hands, don't they? Like when the baby becomes able to sort of move a hand sufficiently to get it in its mouth so it can suck it, and it does that all the time. And that is you can very directly consider that in a Bayesian model of they have these weak low confidence predictions about what things do, and as they get more evidence from how things happen, they get those predictions get more accurate, and they can build them up, and they get a more precise sense of how the body works. The last part of the book is very much about how, Bayes describes our brains and how they work, which I think I love that. I found that stuff fascinating.
Yeah, no, super interesting. In a way, I guess the neurons are voting by the rate of not the rate of firing. The rate of firing, I guess. And how many are firing to cause the next one down the line to fire or not, based on a kind of a Bayesian calculation of the probability of this information coming in being true.
Yeah.
Yeah. So after reading that, though, I got to thinking, the older I get, the more set in the ways, or the deeper my priors are about things that just probably can't be true. But then I worry about, I don't want to be that guy who 500 years from now, they look back and go, how could these people in the 21st century believe this crazy shit? Because now look what we know to be true. Why are we missing things now? Like, say, 500 years ago, they wouldn't have been able to anticipate Einstein or whatever. And, you see what I'm saying? Yeah.
But I tell you what that reminds me of, though. Did you ever read the Asimov essay, The Relativity of Wrong?
Yes, I love that. I quote that. Yeah.
And I think there's lots that you are right that we will be wrong about stuff in 500 years. What we say now will be wrong, but it'll be closer, I think, on average to what the right answer is than what people believed 500 years ago, right? Hopefully we get our probability mass gets put onto a narrower and narrower thing around the true answer. I hope, over time.
Yeah, how does that quote go? Let's see. When people thought the Earth was flat, they were wrong. When people thought the Earth was round, they were wrong. It's an oblate spheroid. But if you think that thinking the Earth is flat is just as wrong as that it's round, you're wronger than both of them put together.
Yeah, right? No, it's a great line. Yeah.
But, again, then there's other things that can't be true versus they could be. There could be a bipedal primate still running around the hinterlands of the Himalayas or Canada or whatever, Bigfoot, Yeti. But my priors are low because, they've been searching. We've been hearing stories about it for centuries. And people have gone searching. They never come up with a body. It's always this kind of grainy videos and blurry photographs. And if you kind of squint and use your imagination, you can sort of see a body in there, whatever. It's a guy in an ape suit, something like that. So therefore, I can say maybe, but probably not at this point because they've been searching for so long.
Yeah, I think that's... It's the can't prove a negative thing, right? Well, actually, you can't prove anything. You can't. You can't prove negative is true, but it's also true that you can't prove a positive, right? You can't prove that you're not hallucinating. Descartes' evil demon, brain in the jar stuff. You can't ever be certain about anything. But when people say absence of evidence isn't evidence of evidence of absence, they're wrong. They're wrong. Like it is evidence of the absence of unicorns that no one has ever seen a unicorn. Right? It is not perfect evidence. There may be a unicorn, in Central Park somewhere that no one's found. But it is pretty unlikely because we've looked in most places. Mermaids, Bigfoot, anything like this. It is your Bayesian prior that these things exist should be quite low because they're half human, half fish hybrids seem pretty unlikely. But the fact that no one has ever seen one, despite having spent, despite now the seas being full of ships all the time and us having explored lots of it in deep sea submersibles and things, that should reduce your belief in that already fairly unlikely. But and the fact that the fact that it's a negative doesn't mean that you can't get evidence for that thing. It's just the idea that evidence of absence isn't absence of evidence isn't evidence of absence is just flat wrong. Like philosophically, just flat wrong. It absolutely is.
Yeah. Yeah, because if this is true, then we should see the following. And the more you dig or look or whatever, and you don't find it, well, then you should keep piling up those lack of evidence as evidence of absence. Now the SETI people will say, well, we haven't really been looking very much, the search for extraterrestrial intelligence. Yeah. That's true. Okay. All right. Well, keep looking. So I guess it depends on the scope of the horizon that you're searching.
It does, of course. Yeah.
They have a long ways to go.
The galaxy is big. My prior that, or the universe is even bigger. My prior that there's life on other planets is fairly high. It wouldn't, I'm not saying it's definitely true, but probably higher than 50-50 because there's so many planets for it to be on. So I think it's whether or not there's one. My prior that there'll be one in a place that we can detect, maybe somewhat lower. I don't know, but it doesn't seem unreasonable to keep looking. We haven't searched a decent. There's a huge search space, and we haven't really searched much of it. but we've
Yeah.
searched a lot of the Earth, and there hasn't
Yeah.
been Bigfoot. And and they are the same for aliens on Earth. And it is the same thing. There is the more planets we look at and don't see evidence of free oxygen in the atmosphere or whatever superstructures around the star like a Dyson sphere or whatever, the more we don't find that. We predict that we should find them if we think that these things are real, and the more that prediction doesn't come true, the less confident we should be in our prediction. That's just, again, it's just the Bayesian maths.
Yeah.
It's a slower process than it would be for Bigfoot.
Here's how I do that Bayesian calculation with UFOs. I use Leslie Kean's book, UFOs, Generals, Pilots, and Government Officials Go on the Record. She's a pro ufologist. She absolutely thinks they've been here. She herself says that roughly 90 to 95% of all UFO sightings can be explained as weather balloons, flares, sky lanterns, planes flying information, secret military aircraft, birds reflecting the sun, planes reflecting the sun, blimps, helicopters, the planet Venus, Mars, meteors or meteorites, space junk, satellites, swamp gas, spinning eddies, sundogs, ball lightning, ice crystals, reflected light up the clouds, lights on the ground or lights reflected cockpit windows, temperature inversions, hole punch clouds, and the list goes on and on.
Oh, so we didn't start the fire. Sorry,
that's right. Yeah. So, a new sighting comes up. It's a UAP. What is it? Well, there's a 95% probability it's in this list. So what are the chances that it's in the other two bins? That is Russian or Chinese drones, spy satellites, or aliens, right?
Yeah.
But right off the bat, it's very, very, very unlikely to be one of those other two.
Yeah. I mean, and again, it's the sort of thing that would take fantastically precise evidence, because my priors are that you can't travel faster than light, and there's not, it would be very weird for an alien civilization to turn up in our skies and only go and visit like peasant farmers in the Urals
New
or something
Mexico.
like that. Yeah, exactly, New Mexico. But so what's going on? Why should I believe this over the much more plausible explanations that it was light reflecting off clouds in some weird way, or a flock of geese? These just, again, you need extremely confident, extremely precise evidence to shift the very, very confident priors that I have on this sort of stuff. And if someone provides that evidence, I will shift my belief. Very happy to do it, but it needs to be more precise than any of the evidence anyone has provided me so far.
You know what example I use for that? The Chinese spy balloon.
Oh yeah, classic.
That drifted over the United States for days. With thousands of photographs, high resolution. Planes flew up, took pictures of it from above. They shot it down. They have the debris. No one asks what the qualifications were of the pilot that saw the Chinese spy balloon, or how good his vision was, or how his training to spot things in the sky. No one cares, because we all could see the Chinese spy balloon.
Yeah, yeah, exactly. Or if no one asks about, if there's a new species of deep sea animal is discovered, we've got the body, or we've got the photos, and we're quite happy. They send down Alvin or whatever submarine to, we've got the images, and it's really high quality. And why do we, we don't then say, well, what sort of camera was it filmed on? What sort of, what are these guys' qualifications? What's their financial incentives? Whatever. We just, we've got this incredible image of this, I don't know, vampire squid or whatever it is. Well, you wouldn't. There's no mermaids. I've never had that for mermaids. So I don't care how trustworthy the guy telling us is.
Right. Yeah. So let's talk about the replication crisis. We can kind of wrap it up here with this kind of larger problem in the social sciences. So this starts with the Daryl Bem experiment. You want to explain that and why we're skeptical?
Yeah, sure. So, I mean, firstly, Daryl Bem was doing what most psychologists would consider a completely normal priming experiment, right? He did so priming in psychology. A priming experiment is when you give someone a prime. Obviously, so for example, you make them unscramble some word like doctor, and then if you give them another set of letters like NUERS, they'd be more likely to interpret it as nurse than they would as runes or something, whatever the alternative one is. And that's just, you're primed to then look out for these things. And people then went through this whole thing of finding these primes had these apparently incredible impacts on our behavior. So like John Barge was the famous one. He said, priming people with words like bingo and Florida made them walk more slowly out of the experimenter's office, out of the lab, because they'd been primed with the idea of being old. For the idea that Florida means old and is weird to British people, but apparently is, I guess, shuffleboard playing retirees for you guys, and what Daryl Bem did was exactly that, except that he turned the Time Lord around. He gave the prime after the person made their selection or whatever, and so what he apparently showed was that in a series, lots of different experiments within this one paper, that people were statistically significantly more likely to detect I think it was a pornographic image instead of a plain one, or that they would be more likely to find an attractive image rather than an unattractive one. So if it after, but they would only be shown it after they made the decision of which picked. And he said this was evidence for psychic powers. I mean, the trouble is, right? For a start, as we've been saying the whole time, I'm not going to believe this unless the evidence is incredibly strong. Now, he did say that the probability value was very low that this would happen, but that it was the replication crisis, which is what we're talking about. That has just shown that a lot, with the Florida experiment and so on, it has been shown that a lot of these things were done with too small sample sizes. When other people try and replicate them, they can't find them. And with the Daryl Bem thing, the same thing has happened. He remains extremely confident that that the psychic powers are real, but other people, non-believers trying to replicate his findings, consistently find nothing at all. And the best predictor of whether or not an experimenter will find evidence for psychic powers is whether they believe in them in the first place.
Mm-hmm. Experimental effects there, yeah.
Yeah.
Yeah, so, but you can also ask a broader question, what's more likely that 400 years of physics since Newton is all wrong and some social psychologist got it right by showing porn images to undergraduates?
Yeah.
Or that there was something wrong in his methodology. Okay. So,
exactly that,
yeah. There's your what's more likely question. That's kind of a Humean question also. But you do wonder, does there need to be an underlying mechanism for the psychic powers, say? Because it's from the history of science, we didn't understand the mechanism behind Darwinian evolution until really we understood DNA, which is, almost a century later.
Yeah.
Or the Alfred Wegener's, the continental drift theory. Without a mechanism, how could continents just float around the globe? This is not possible. This is a crazy theory. I know they kind of match, but maybe that's just a, byproduct of the way we look at maps or something. It wasn't until the 60s when it was clear that the continents are kind of floating on these magma cells or whatever they are, and that they could move. And then it became, kind of accepted. So I guess as a deeper philosophy of science question is, do you need both the data and the mechanism underlying it to accept it, or can you accept it without the mechanism?
Well, I think you can. I mean, it's like everything else. You have degrees of confidence in your hypothesis, and those degrees of confidence should be influenced both by the strength of the experimental evidence and by the theory underpinning it. Like, to bring back the loneliness example that I was talking about earlier on, people saying it's as bad as 15 cigarettes. Well, I can see a very good causal explanation. There's a good theoretical reason to think that smoking affects how cells replicate and causes DNA damage, and that can lead to increased likelihood of out of control replication of the cells and therefore cancer. I don't see how the same is true for loneliness, and so I need more strong evidence to convince me that this thing is a real causal effect. But if the evidence was really strong for, well, as it was for evolution, or as it became later for the continental drift theory, the job is to then, if the experimental evidence is huge, then you need to find a theory that explains it, and maybe it's a theory that explains why this evidence isn't actually real or whatever. But maybe it's an experiment about evidence, a theory that explains, continental drift, magma cells underneath. Funnily enough, Harold Jeffreys, who's one of the great Bayesian sort of prophets, I don't want to say that, but one of the great thinkers of Bayes in the mid 20th century. He was a geologist and was thinking very much about the cell, about the contents of the world, the sort of the core and the mantle. And the reason he wanted to use Bayesian methods was because he didn't have access to that much. It had so much noisy data that if you're using frequentist methods, you have to discard all your previous data every time and just do you use this experiment. Whereas he's like, I haven't got very much data. I want to build on what I've got and add new results of experiments into the existing one and use them as my prior. So Bayesian theory, very much part of the continental drift story.
Yeah, that's a great example. I hadn't thought of it that way. Well, so you'll often hear the ESP psychic people say it's like quantum physics. It's spooky and weird. When I bring this up with quantum physicists, they go, yeah, but we have thousands and thousands of experiments with very precise, the 6 places after the decimal point predictions. And, the ESP people have nothing like that.
Yeah, exactly. I mean, this is the fundamental thing, right? It's all predictions. If your theory predicts stuff that then comes true, that is consistently confirming that is confirmation of the theory. It's not rock solid confirmation. There could be other, but if your hypothesis makes a specific prediction that other hypotheses don't make, and then that prediction comes true, that is evidence for your hypothesis. The mechanisms behind it are a separate question. It's great to have theoretical evidence, basis for it, which can then back it up. But quantum theory, relativity, they both they're very counterintuitive. They're very weird to us, but they make phenomenally precise predictions, which then come true. And that is really good evidence for something. I mean, that is, that's a lot of the point of this book is that predictions are key to intelligence. To everything else, if something is a theory is good, a belief is true to the extent that it makes true predictions. Predictions that come true. And if your belief doesn't make true predictions, then you should downweight your belief in it.
Yeah. Everything is predictable. Okay, what do you mean by predictable? Let me read a quote from Pinker's book, Rationality, in his discussion on Bayes. Why can't we predict who will attempt suicide? Why don't we have an early warning system for school shooters? Why can't we profile terrorists or rampage shooters and detain them preventively? The answer comes out of Bayes' rule. A less than perfect test for a rare trait will mainly turn out false positives. The heart of the problem is that only a tiny proportion of the population are thieves, suicides, terrorists, or rampage shooters, the Bayes rate. Until the day that social scientists can predict misbehavior as accurately as astronomers can predict eclipses, their best tests will mostly finger the innocent and the harmless.
Yeah, I mean, it's true. I mean, that when you've got low confidence, like weather is another example. Like when things are chaotic and complicated and there's loads of inputs and lots of ways it can behave, your predictions are going to be necessarily noisy, and you can only do them sort of in a probabilistic way. But like you can predict fairly confidently how many suicides there'll be in the UK next year. I could, by looking back at historical data, I could probably get that right to within 15% or something, but and murders or car crash deaths or anything. But where each individual one will be, earthquakes, can't do it, and it is so. It is absolutely your predictions can only ever be statistical in certain senses. I mean, you can predict when the next eclipse will be for the next 4,000 years.
Yes.
That's different. That's because there is such precision about it. But once you start getting chaos and complexity, and it's the predictions start becoming stochastic, much more statistical and much more probabilistic.
Yeah. Let me just read this on the Fragile Families and Child Well-Being Study, in which 160 teams of social scientists were provided with detailed data collected over 15 years on 4,242 at-risk families from the Fragile Families and Child Well-Being Study database. They were tasked with predicting 6 life outcomes, for example, child GPA, family marital hardship, parental eviction or employment, based on various causal variables such as employment, income, education, health, environment, relationship with extended kin, marriage attitudes, fatherhood, father-mother relationships, interviews, and in-home assessments. The research teams employed not only the usual statistical tools and methods all social scientists are trained to use, but AI machine learning programs as well. The results were underwhelming, to say the least. Quote, even though the Fragile Families data included thousands of variables collected to help scientists understand the lives of these families, participants were not able to make accurate predictions for the holdout cases. In other words, you could say like, well, a kid from a cohort here is less likely to get into college or less likely to make a lot of money or whatever than a kid over here. But what about that kid right there? No idea.
Yeah, I mean it's going to be the case for a lot of things. I mean, this is there's been a lot of talk about AI used to predict parole and all that sort of stuff. And I mean, maybe I imagine they do. But the one thing I will say, right, and I talk about this in the book, is that algorithmic things like this are often do better than humans do. Humans are really rubbish at this as well, right? As you know, psychologists or social workers or whoever meet people and make their predictions of who will do well and who won't, and they are systematically wrong. You know, and that is it is often the case. I think it was Paul Mealer, the psychologist, who pointed out that often simple algorithmic systems where you just say, you know, put in a few biographical details, often outperform human predictions on a lot of these things. But it's only because the base rate of human predictions is so rubbish to begin with that the algorithm one can do better. And there probably will be quite a hard limit on how good prediction can be, and for the same reason that there'll be a hard limit on how good predictions of weather can be. That it's a chaotic system. There's so many. You need to know so many variables to make a good prediction of the outcome, that you're just not going to be able to predict them all. And if to know all the sort of starting conditions, and then to be, you know, and then it's be computationally enormously difficult to include them, all the ones you do have. So yeah, I think there'll be a real hard limit on how well AI can predict individual humans or society. And I think that was the basis of the foundation. Just to come back to Asimov, that was the basis of the Foundation novels. And I think even as a kid, I was like, I don't believe we'll ever get this good at predicting stuff.
Yeah. No, and I think part of the problem is just contingency and the chaotic nature of complex systems, of which an individual human is. And therefore, like, for example, this, you know, suicidality, you know, there's a database of people who attempted suicide and then failed. And so you can interview the person. And most of them say, I don't know why I did. I don't know what came over me. You know, I was just depressed. I just had a bad day, and that was the day. Or another case, a guy said, I'm going to walk across the Golden Gate Bridge, San Francisco. If somebody smiles at me, I won't kill myself. Apparently no one smiled at. He left a note. You know, it's just kind of these kind of random things. You know, will Putin invade Ukraine, or will Putin stop? Whatever. Maybe Putin doesn't even know what he's going to do, you know, on any given day. You know, he gets up and goes, well, fuck it. Today is the day I'm going to whatever. You know, and so the closest Russia expert, how would they know what he's going to do?
Funnily enough, on the suicide thing, I remember reading a guy who exactly that. They had that sort of fit of like a moment of awful lowness, and he said he jumped off the bridge and he realized halfway down that, you know, all these problems in my life. All these problems are solvable apart from this one big problem that I've just jumped off a bridge.
It's right. Right.
And I don't know how to deal with that one. Luckily he lived, and it was all right. But yeah, I mean, that's exactly it. Like, how people's own minds are unpredictable. I mean, I think, you know, by the time the tanks are on the border between Russia and Ukraine, you can certainly raise your probability estimate, can't you? You can say on like when, you know, with no more information, if you tell me what is it raining on a given day in London, I'll say about 1 in 4 chance. If you tell me that it's really cloudy outside, I'll raise that up. It's, you know, standard conditional probability. Is Russia going to invade Ukraine today? Well, on a random given day, probably not. If I know that they've parked a bunch of T-72s on the border, I will increase my probability estimate, right? And so you can do some. You can. It's not that we're flying blind. It's not that the future is completely unknowable, but it's a lot of it's murky, and the bits we can see, can only see a few days out. You know, it's always probabilistic. We're always sort of raising and lowering our estimates of whether something's true or not.
Yeah. Well, that's why I love this theory, because it applies to so many things. Your book covers all that. Here it is. Get a copy. Listen to the audio. It's also quite good. You have a different cover in the UK, right? They always do that.
Yeah. They're different companies publishing them. I love them both very much. I couldn't ever tell you. You know, it's like choosing between your children. Yeah.
Well, I as long as they keep the title and subtitle the same. I always hate that when they have a different title or subtitle of a book, and you go, "Oh, he wrote another book." Oh no, it's the same book.
they changed the name of my first book for the paperback, and it's really thrown a lot of people saying, "So did you write another one?" No, they just changed the name. Oh yeah. God. Anyway,
sales are better under this title than that title.
Yeah, well, I hope so. Yeah. Anyway,
all right.
That was a lot of fun. Thank you very much for having me.
Very super interesting. All right.